Hi, everybody. This is section 3.4, Find New Slope of Lines notes for geometry. This is mainly a review of how to find slope and then how to also graph some lines. Just as a kind review here, let's get started. Our slope can also be signified by the letter M. Our rise is our change in y values. And our x is our run is our change in x. So throughout this video, remember that you can pause it, fast forward, rewind. Specifically pause, try the problems first from your notes, and then come back to the video and see the answers. So example number 1, match each graph to the correct type of slope it exhibits. If you look at this first graph, that is a vertical line, that is a slope that is undefined. You'll always see that whenever you have something with no slope. Y, it starts in the next one there, the y and the x, they start at the bottom left and then go to the top right. That's a positive slope. Next one starts in the top right and goes downward to the bottom left, to the bottom right. That's a negative. And then anytime that you see a line that goes straight across, that's going to be a slope that is 0. So how to find the slope of the following line? Usually you want to look for where your line crosses your coordinate graph perfectly or kind of matches up so you can get 2 points. So here's 1 point, here's another. And then in order to find your slope, you want to count your spaces. So up 1, 2, 3, 4, and then over to the right one. So think of it as anytime that you go up or right, that's a positive movement. And then anytime that you go down or left, that's a negative movement. So for example, here I'll do this in blue. I could have went down, could have chosen 2 other points and went down 1, 2, 3, 4. So that would have been negative. And then it would have went left, and that would have also been negative. And then I still would have gotten my solution or my answer 4. Pause the video, try example 3. Find the slope of the following line. Again, I want to try to find 2 points that go through perfectly. So in this one, I go up 1, 2, 3, 4. You always go up and down first. And then I'm moving left 1, 2, 3. That's a negative 3. And then I can just rewrite it with my negative out front. Finding slope when you have 2 points that are given. First off, you want to label those points x1, y1, and x2, y2. Then you want to plug them into the equation y of 2 minus y of 1 over x of 2 minus x of 1. Might be good to have this equation somewhere in your notes. Find the slope of the lines connecting the points 1, 3, and 4, 2. First one here, I'm going to label my points. And then I'm going to use that formula, y2 minus y1 over x2 minus x1 to get 2 minus 3 over 4 minus 1. So negative 1 over 3. Again, pause the video, see if you can figure out the next one before we do it. Here, using my formula, I've got 7 minus negative 5 over 3 minus 6, which gives you 12 over negative 3, which is negative 4. Two new postulates, or kind of non-new postulates. Slope of parallel lines. So the slope of parallel lines have the same slope. So 2 lines are parallel if and only if they have the same slope. Whereas slope of perpendicular lines, 2 lines are perpendicular if and only if the product of their slope is -1. So that means if we took both slopes together and we multiplied them, we get -1. You can also see that two slopes are perpendicular if you look and you find out that they have opposite reciprocal slopes. That's something as well that we can take a look at. Finding the slope of each line here, and then it says which lines are parallel. First thing that we want to do is we want to find the slope of every single line. So go ahead and pause the video and try that out on your own. Now that we're back, line A, line B, and line C, hopefully you found their slopes to be -1/4, -1/3, and then -1/3. With this, you'll find that lines B and C are parallel since they have the same slope. Well, just a clarification, you can also write that as B parallel to C. It's that parallel notation that we use. Taking a look at example 7, we don't have too much left to go here. Line M passes through -1, 3, and 4, 1. And line T passes through -2, -1, and 3, -3. Are the two lines parallel? Try this problem on your own first, and then you can look back at what we do here in the video. Okay, first off, I'm going to use line M. I'm going to use that y of 2 minus y of 1 over x of 2 minus x of 1. So 1 minus 3 over 4 minus -1 gives us -2 over 5. Then for t, we have -3 minus -1 over 3 minus -2, which gives us -2 over 5. So M is parallel to T. And this is because of the slopes of parallel line postulate. You could also just simply state that M is parallel to T because the slopes are the same. Moving away from parallel lines, let's take a look at these two lines that are supposedly perpendicular. Find the slope of the line K using the slope formula, and then use what you know about perpendicular lines to find the slope of the perpendicular line without doing any algebra. I think one of the first things that we probably want to do in this type of problem is find the slope of K. So let's go ahead and let's find the slope of K based off of these points. It says we have to use the slope formula. So line K has the points 0, 3 and 5, 2. 2 minus 3 over 5 minus 0 gives us -1 over 5. Then it says, use what you know about perpendicular lines to find the slope of the perpendicular without doing any algebra. Remember, whenever we looked at that parallel perpendicular postulate, it stated that if I had one slope multiplied by another slope, I should get the result of -1. So if I put an x in here, I could actually solve this out. -1/5 x is equal to -1. Multiply each side by 5, -5. I get x is equal to 5. So the next line, we'll call this line, line N. Line N slope is 5. based on that slope of perpendicular lines postulate. Next example here, we've only got about 2 more after. Line N passes through 0, 2, and 6, 5. Line T passes through 2, 4, and 4, 0. Is N perpendicular to T? Explain. Go ahead again, pause the video, try and see if you can figure this out on your own. Okay, now that we're back, we're going to take a look at finding the slopes of each of these. So line N, we've got 5 minus 2 over 6 minus 0. Gives us 3 over 6, or 1/2. And line T will have 0 minus 4 over 4 minus 2. Gives us negative 4 over 2, which is negative 2. Based off of looking at the one slope being 1/2 and the other slope being negative 2, are these perpendicular? Your answer should be yes. They are what they call opposite reciprocal slopes. And if I took, based on that slope of perpendicular lines, if I multiply them both together, I should get negative 1, which I do. So N is perpendicular to T by the slopes of perpendicular lines postulate. Example 10, find the value of y so that the line that goes through the points 3, 2, and 9, y has a slope of 5 over 3. So this one, we're actually looking to find out what one of our coordinate points is, given that we have our slope. Try it on your own first. See if you can challenge yourself to finish this problem, and then go ahead and hit play on the video. Now that we're back, we're definitely going to look for the slope. We're going to use that slope formula. So m is equal to y of 2 minus y of 1 over x of 2 minus x of 1. The reason I put m in there is because that's our letter that stands for slope. And since they give us a slope, we can actually plug that in. 5 over 3 is equal to our different coordinate points. For the sake of this one, I am going to show you which is which whenever I'm doing this. So I'm going to label all my points. So in this case, I have y minus 2 over 9 minus 3. So 5 over 3 is equal to y minus 2 over 6. I can then do a couple different things from here in order to find the y. One of them, though, is to cross multiply. So I'm actually going to multiply across. I'm sure that some of you are familiar with this type of method. So I have 3 times y minus 2 is equal to 5 times 6. So 3y minus 6 is equal to 30. I'm going to add 6 to both sides, so 3y is equal to 36. And then divide by 3, so my y value is equal to 12. And if you want to, you can even check your work by plugging the 12 back in to your coordinate points, trying to solve for your slope and making sure that you get 5 over 3. Last example for today is a candle is lit in the center of a table at the beginning of a dinner party. Its height decreases by 1.75 inches every 25 minutes. At the beginning of the dinner, the candle was 8 inches tall. Part A, make a table showing the height of the candle at 25-minute intervals. Part B, write a fraction that represents the decrease in height for each minute the candle burns. What does the numerator represent? Before you try this, I'm going to ask you, please pause this video and try it on your own. Now that we're back, we want to make a table showing the height of the candle at 25-minute intervals. So I'm going to go ahead and I'm going to draw a table out. I'm going to label what I have here. So in this case, I have My first one is going to be time in minutes. And then my other one is going to be height in inches. So at 0 minutes, which is the start, it is 8 inches tall. Every 25 minutes, it decreases by 1.75 inches. So in the next 25, 8 minus 1.75 is going to give me 6.25. At the end of 50 minutes, I'm going to subtract another 1.75, and I should get 4.5. And then 75 to 2.75. If I do one more, just to show you after 100 minutes here, take a look. After 100 minutes, then this should be down to 1. And then because it decreases by 1.75 every 25 minutes, by the next 25 minutes or before that's even up, there should be no candle left. Remember, this is a real world situation, so we don't have any negative candle. We just don't have any left. It's all gone. So the next part B, says write a fraction to represent the decrease in height for each minute the candle burns. Write a fraction to represent the decrease in height. Okay. So negative is negative 1.75. Decrease in height. And then it says for each minute the candle burns. Well, in this case, it does this for every 25 minutes. So we're just going to have to divide negative 1.75 divided by 25 to tell how much of the candle actually decreases per minute. So if we go ahead and do that, we should get approximately negative 0.07. Now it's also asking us what does the numerator represent? Okay. Because if I put this over 1, this is essentially the slope in decimal form. Of the decrease in height in inches per minute. And if you didn't want it in decimal form, you could also have it as negative 7 over 100. Please make sure to do the corresponding homework with this assignment. And once again, you always have the opportunity to pause this video, go back and rewind, and view whatever you need to view. Take care.